Okay, we're talking about natural numbers, counting numbers. We want to prove that n to the fifth minus n is divisible by 30, meaning it's a multiple of 30. It divides evenly. Divisible means, in this context, divides evenly. No, the remainder is zero. So we could make a table. That's a possibility. But the caveat is that the tables are not proofs. Just to see here what's coming down. Now we have n here. N is say 2. We have 2 to the fifth minus 2. That's going to be 30. Try 3. 3 to the fifth is what is that? 243. So 3 to the fifth is 243. Minus 3 is 240. It's divisible by 30. This is going to be 4 to the fifth minus 4. This is 1024 minus 4. That's 10, 10, 20. These digits add up to 3, so it's divisible by 3, and since it ends in a 0, it's divisible by 10. So if something's divisible by both 3 and 10, it's divisible by 30, since those numbers are relatively prime. Okay. So it looks like we're on the right track here. We haven't found an exception, but no matter how far out we're going in the table, it's not going to prove this proposition. So let's just factor here. How we can factor again. We can factor again, difference of squares. Now just we can arrange these like this. Now this expression has 3 consecutive natural numbers, n minus 1, n, and n plus 1. So every 2 consecutive numbers are divisible by 2. One of them is divisible by 2. If every other number is divisible by 2. If you have 3 consecutive numbers, they're going to be divisible by 3. Every 3 consecutive numbers contains a number that's divisible by 3. So if it's divisible by 2 and divisible by 3, it's got to be divisible by 6. So these 3 factors are divisible by 6. Now, all we have to show is that this expression is divisible by 5, because 6 and 5 are relatively prime. So they have the greatest common divisor is 1. So What we need to do is to, if the multiple of 5 occurs here in this group here, uh, in these factors, then we're done. But supposing that it occurs out here, that the multiple of 5 occurs out here. So if this is only going to be a multiple of 5 if when we subtract 5, it's also divisible by 5. If a number is divisible by 5, you subtract 5, it's still divisible. Then the difference is divisible by 5. So this is going to be n squared minus 4, which does factor. So now what you have is you have these 3 in the middle here, and we put these on the outside. So here's the way we reason. Here we have 5 consecutive numbers. So this number must be divisible by 5. So if the number that's divisible by 5 falls here, it's got to be this. That's divisible by 5. If this is divisible by 5, this is divisible by 5, and this is divisible by 5. So the divisibility. So if it falls in this bad zone, it's going to be okay because we have it covered. So now let's try to look at cases. So that's the proof. You have 5 consecutive numbers divisible by 5. It's divisible by 6, 2, and 3, and also divisible by 5, divisible by 30. So what we want to do here is just take a look at here's the this is the just to demystify this. So when we put a 2 in here, we get 1, 2, n plus 1 is 3, and n squared plus 1 is 5. So there you have it. Okay, here if we put it, when n is say 3, we have 2, 3, 4, and 10. So the number that's divisible by 5 fell in the last factor here on both of those. And so that's how that goes. We could try some other numbers, but it gets embarrassing. So remember that I'd like you to press like and try to subscribe. It helps me to give you more content, and that's what that is.